Good afternoon and welcome to Have You Met TypeScript? Our guest speaker today is Sangeeta Nori of General Motors.
Hello, everyone.
And my name is Jennifer Ponder. I am the Front End Track Leadership Fellow at Women Who Code. I'm located in Atlanta, Georgia. Our guest speaker today, Sangeeta Nori, she is the lead software developer for General Motors in Georgia, with a focus on building cloud-native web applications using Angular and TypeScript. She also tinkers with Android development. Outside of her day job, she is a passionate advocate for girls and women in STEM and volunteering and coaching with several organizations. Now we're going to move into our Women Who Code mission, which speaks to inspiring women to excel in technology careers. Our vision speaks to a world where women are representative as technical executives, founders, VCs, board members, and software engineers. And please take a look at our code of conduct. We do want to foster and build a collaborative environment where everyone feels welcomed and that we can all build together. Also, please take a look below at the link. You can find the full code of conduct at womenwhocode.com/conduct, of course. And just some information about the Women Who Code front end track. You can register for events and also become a member at womenwhocode.com/frontend. Also, email us, frontend@womenwhocode.com, if there are any webinar ideas, study group topics, or anything that you'd like to see come into the track. Definitely send us an email. You can find us on social media, on Twitter at WWCodeFrontend, and also on Instagram at WWCodeFrontend1. And we do have Slack available. You can find those links on our Twitter and our Instagram pages. And also, to definitely email us, frontend@womenwhocode.com, if there are any issues with you getting into our Slack. We definitely love to have you, and we'll send you a Slack invitation. Now, without further ado, I'm going to turn it over to our guest speaker today, Sangeeta Nori.
Thank you, Jennifer. All right, I'm going to start by sharing my screen here. So let me know if you can see it when it comes up.
Yes, we can see it.
Awesome, thank you. Well, it's a chilly November afternoon in Atlanta, so let's get to it, into TypeScript. So the title of the talk is, Have You Met TypeScript? So this talk does not assume any previous knowledge of TypeScript. Some knowledge of JavaScript would help, but it's not necessary. So before I introduce TypeScript, let me introduce myself. Like Jennifer said, I work at GM, and yes, I'm very passionate about STEM education. So some of the organizations that I worked with in the past, I did sessions with Girls Who Code. I'm a coach for Science Olympiad at our local middle school. I've been a mentor to someone who did the Moms Can Code bootcamp, and I'm very happy to say that she found a job starting with IBM, in fact, this month. And I'm happy to do this webinar today. You can find me on Twitter at Nori Sangeeta. I welcome feedback. Any questions, comments, please feel free to tweet at me. So let's get into the agenda. So I'm going to start with why TypeScript first. I think it's important to know why you need to learn a new language before you actually learn about it. Then we'll look at TypeScript, what I like to call superpowers. So we're going to talk about the type system, the interfaces, classes, functions, and generics. And the way I have this structured is I have a few PowerPoint slides, and I also have some code samples. So we're going to switch back and forth between the slides and the code samples. And in the end, I've got a bunch of resources which I found very useful, and you can use that to further your knowledge of TypeScript. So let's get started with why TypeScript. So this slide here is actually the homepage of TypeScript. It's the typescriptlang.org. And TypeScript is a language that was created by Microsoft. And if you see here, the main description of TypeScript is that it is JavaScript that scales. So which means the very identity of TypeScript is tied to the identity of JavaScript. So we'll first look at why we need JavaScript that scales, and then look at TypeScript. So what is JavaScript and what are some of the problems with it, right? So if you've been doing front-end development, of course, you know what JavaScript is. And believe it or not, it's been around for 24 years. That's right. That's a really long time in technology area, right? And in this fast-paced world of technology, really, for something to stay relevant for 24 years, you have to rediscover and repurpose yourself. And in my opinion, no language has repurposed itself better than JavaScript. And we'll see how it has done that. Let's kind of look at this slide here, which talks about all the places JavaScript has been since its beginning, right? Since its inception. So 1995, JavaScript was created at Netscape. And in the early stages, really, JavaScript was used for the early internet, right? To make the internet interactive, all your web page animations and, you know, dialogues and validations and such. Now, in the early 2000s, client-side scripting took off and we started to get into the browser wars. I mean, if you probably all remember the Internet Explorer versus the Netscape Navigator fights, right? And there was whose JavaScript version or flavor is going to win out. But fortunately for all of us, JavaScript got standardized and it got handed to a standards body called ECMA, ECMA, and it became ECMAScript. And it kept growing. JavaScript, mid-2000s, you'll see that a whole bunch of new libraries started coming into play to make JavaScript development easier, right? Some of these names you probably recognize if you've been coding for a while, you know, libraries like jQuery, Dojo, and others. So all this up until 2009 was where JavaScript was predominantly on the client side. But in 2009, there was a big shift. JavaScript entered the server-side world, right? And with Node.js, you could start using JavaScript on the server side, which is pretty cool. All right, and then our browsers, the JavaScript engines in our browsers started to get really powerful. So the Microsoft Chakra engine, the Chrome V8 engine got so powerful and they could execute JavaScript so efficiently that you can build full-blown web applications using just JavaScript. And that led to the rise of spas, right? In 2010, you started seeing frameworks like Angular and React and Vue come up and JavaScript heavy web applications started to get built. Awesome, so now JavaScript has really matured. And then in 2013, you could use JavaScript to write desktop applications, not just web applications. You can use it to write desktop applications. In fact, if any of you have used Visual Studio Code, that is a very popular IDE from Microsoft, that desktop application is actually written in TypeScript using this framework. So, okay, you can write desktop applications, and then come 2015, you can even write mobile applications using JavaScript. So you see how it's repurposed. It went from client-side scripting to, you know, libraries, to server-side scripting, to full-blown applications on the web, desktop applications, and now finally mobile applications, right? So that is what I was talking about, how JavaScript has repurposed itself and became really big. Okay, great. So now you know it does everything, runs everywhere on your phone, on your tablet. It's really cross-platform in that sense, right? So you would be wondering, okay, what's the downside? What are maybe some of the problems with JavaScript? And JavaScript, as you all know, is a dynamically typed language. And that is a very debatable thing, whether you know, you like it or not. So dynamic typing, is it good or evil? Now, what do we mean by good or evil? For some programmers, dynamic typing is good because you don't have to put your types in the code. When I say types, I mean things like this is a string, this is a number, this is this class. So that is a typing. And if you don't have to put that, and JavaScript allows you to not specify your types, that is good because your code is less verbose and you have a lot more freedom. You have a lot more power. But like someone said, with great power comes great responsibility, right? Like if you have all this power, it's easy for that power to be misused, especially if you're on a large team. If you're doing a small project by yourself, or if you're on a small team, yeah, you can keep track of the code base. You don't need type system to catch your errors for you. But what if you're in a big company, big team, big project? If you don't have the type system, it can cause a lot of errors, because what you wanted to be a string, somebody else expects a number. When you were going to pass a certain object, somebody else is expecting something else. And that mismatch can cause a lot of runtime errors. And that is one of the big problems with using plain old JavaScript, the typing. And a lot of big companies like Google, Microsoft, they all felt this need, and that was one of the big reasons for TypeScript to be created. The next thing is tooling. And sometimes I really wonder if, all the JavaScript developers secretly dream, and hope for this fairy godmother to appear in their dreams, and they can get one wish, and what they would ask for, and it would be that if they can get better tooling. Right? Because, if you are a programmer in any other language, you probably have a fancy IDE, and you press dot, and there's code completion, and there's all kinds of help that you get from your IDE, and you're used to it. But now, suddenly, if you're programming in JavaScript, for the longest time, all you had was a text editor, and you had to rely on your own skills, and the tool was not giving you much help. But with TypeScript and the types, now the IDE can give you the help you need and make coding a lot more easier and pleasurable, in my opinion. So that's the second big reason to adopt TypeScript. And the last one is you can use future JavaScript features right now in TypeScript. And let me explain that. So JavaScript, as you know, keeps coming out with new versions every time. There's ES 2015, 2016, we had ES 2019, and each time a new feature comes out, you may not be able to use it because maybe your client is stuck on a browser that doesn't support the latest version. So even though you want to use a new feature of JavaScript, your hands are tied. But if you use TypeScript, you can use all the latest and greatest features of JavaScript, but you can say when you compile it, and I'll show that in a bit in the presentation, you can say that I want to use the latest version, but when you compile my code, take it back to version, 2015. So you write code in the latest version, but you execute in an older environment, and you can execute in any environment or version that you want. So that, in my opinion, is a huge benefit because you can play with the newest features, you can write code using the newest features, but you're not tied to your client's browser or whatever, right, version. So there you have it. And this is a kind of a succinct summary of what TypeScript is. So at the heart, TypeScript is JavaScript that scales because it solves the two problems that we saw before. So it's useful to write big applications, large-scale applications. Then it's a superset of JavaScript, which means any valid JavaScript is also valid TypeScript. And of course, it's open source. Microsoft has made it open source, and TypeScript is available on GitHub. So if anybody is interested in taking a look at the code or contributing, they welcome all interaction and contributions. And lastly, it is cross-platform like we saw. It runs on any browser, any host, any OS. So it's a big advantage. It's a big draw for TypeScript. And this is just like a picture version of what I've said so far. So essentially, what is TypeScript? It's your JavaScript with a type system, which is optional and static. Plus, it brings a lot of tooling with it to make your life as a developer easy. Okay. This is just a slide to show how popular TypeScript and JavaScript are. So I know it's hard to read, but basically on the x-axis, you've got GitHub ranking, and on the y vertical, you've got the Stack Overflow ranking. And you can see that JavaScript here is the leader of the pack, so in terms of popularity. And TypeScript here is in number 12th spot. And that's actually impressive because TypeScript was only created 7 years ago. The first release of TypeScript came out in October of 2012, right? So for a 7-year-old language, jumping all these other languages and coming to the 12th spot is actually quite impressive. And the popularity of TypeScript also has to do with the popularity of JavaScript, of course, right? So as long as JavaScript stays popular, TypeScript's gonna, remain relevant. And if you are doing Angular development, you have to use TypeScript. You can also use TypeScript for React and Vue. Angular was one of the first partners for TypeScript, but React and Vue are also right there. This is just a slide to show that TypeScript is being used and adopted by a lot of companies. You see some big names here, recognizable names. So definitely not, in a small scale. It's got widespread adoption. All right, so now let's get into, how do you get started with TypeScript? So it's pretty easy. You do an npm install. If you have Microsoft Visual Studio already, you can just install it within the IDE. But if not, this is probably the easiest way to get started. -G option here just says that you globally install TypeScript. So once you install TypeScript, you're good to go. It's got a compiler, and the way you invoke the compiler is using the TSC command, which stands for TypeScript Compiler. And all TypeScript files by default have this .ts extension, which stands for a TypeScript file. And you can just get started with plain old JavaScript. You can do a hello world.ts and put a simple JavaScript statement in there, and that will compile into TypeScript. This actually, the current version needs to be changed. I made these slides a week or so ago, and actually, believe it or not, in the last week, they came up with a new version. So there's a 3.7 right now, which is the latest version. So the TypeScript compiler, let's take a quick look at that. And that is where I'm going to jump into some code as well. So what does the TypeScript compiler do? It transpiles, and transpiles is the word for converting the TypeScript code into JavaScript code. Because remember, the TypeScript code cannot run in the browser. The browser only can run JavaScript code. So when you write code in TypeScript, it needs to be converted to JavaScript before it can run. And that is the job of the compiler, to convert it into the executable JavaScript. The TypeScript compiler is itself written in TypeScript. And there's a whole bunch of TypeScript options, compiler options that you can, customize, which we'll look at right now. And because there are so many compiler options, it's hard to give all those options on the command line when you're trying to compile. So it's easy to put them all in a file, all your compiler options in a file, and that file is typically called the tsconfig.json. And if you're starting a brand new project, the way to create a default tsconfig.json is to give this command, tsc --init, and it creates a default file with all the default options. And this is where, let me switch to my code here. Jennifer, are you seeing my code base?
Yes, I can.
Okay, perfect. So this file, the tsconfig.json, has to be at the root of your project. And it has a lot of options, and the good thing is there's a lot of documentation. I'm not going to go through each one of them, but let me point out the few things that are important when you get started. So the first one is the target option. If you remember, I talked about how you can use the latest version features of TypeScript, but then you can specify what version of JavaScript you want it brought down to, and this is where you do that. So you can, right now I've got this value ESNext, which means I'm saying, hey, I want to use the latest JavaScript version, but you can specify whatever version of JavaScript you want. So if your client is on 2015, you can specify that here, and the TypeScript compiler will generate code to that version. The next one, the lib, is where if you want certain libraries, let's say you're doing a web application, right? And you're using a certain library. You want the types of that library to come into your project. You specify that here so that TypeScript can help you with not just the types in your code, but it can also help you with types in the third-party code. So here's where you specify those libraries. Watch is to say that every time you change a file, you just want TypeScript compiler to incrementally, keep generating new code. This is one of my favorite ones, strict. And we'll look at it even later. There's a slide about this. And what this is so TypeScript gives you a whole bunch of type system rules and checks and balances, but it doesn't say that you have to follow all of them at one time. It gives you a lot of flexibility. And it says, okay, if you only want to follow them some, you can do it. And that is where the strict flag comes in. So if you say strict equals true, and there's a whole bunch of strict things that you can tell TypeScript to do, then it'll say, okay, I'm going to turn the heat full on. I'm going to make sure you follow all the rules. But sometimes that's not ideal, right? Especially if you have a previous code base and you're trying to migrate to TypeScript. Maybe you want to migrate it slowly. Maybe you cannot migrate the entire thing at one shot. So in such circumstances, you can say, okay, I only want certain rules to apply, and I want you to not be strict with me. So this is where you set all those things. No emit, again, goes back to the flexibility that TypeScript gives you. You can tell TypeScript, hey, if I don't follow all the rules, don't generate any JavaScript code. Or you can tell TypeScript, I may be breaking some rules, but even though I break it, generate my JavaScript code. So that's what this no emit is. So you can control how strict you want TypeScript to be with you. I won't go through all the others, but I thought these top few are kind of important to to get an understanding of when we get started with TypeScript. So that's the compiler. We just saw that, and how you can customize the TypeScript compiler to your needs. Now let's talk about the type system, right? I mean, after all, it's the crown jewel. It's the raison d'etre for TypeScript, right? And type system is optional. And like I was just explaining, you can say, I want you to be strict with me. I want to put types all over my code base. Or you can say, I don't want you to be strict. I'm only going to put types part of the code base or some types, and TypeScript is fine with that. That is what optional means. Erasable. The types that you put in are completely gone from the JavaScript code that gets generated. So you don't have to worry that, oh my God, I'm putting all these types in my TypeScript code. Will that slow the performance? Will that have an impact? Will my website be slow just because I put types in my code? And the answer is no, because eventually everything gets converted to JavaScript, and JavaScript does not have any types. So it is completely erased, and it does not have any runtime impact. And like we talked about, any type errors don't block the JavaScript image, which is a good thing. So it's like a dial. You can turn the heat on full on, or you can, reduce it to just where it suits your needs. So what are types? All programming languages offer some kind of typing or the other. So we have some basic types, like we've got numbers, string, booleans, nulls, undefineds, and so on. TypeScript gives you an enum type. It gives you arrays and a special type called tuple. So let's switch to code again and look at these types in action. So let's start with basic types here. So this is just an example of how you can define a Boolean and give it the value true. And this is an example of a simple string type. You're saying my str is a string type, and you gave it a value of hello world. So this colon right here is what is called as a type annotation. So you present this colon, and then you specify your type right next to it. That's how you do types. Now, TypeScript gives you what are called as a literal type. If you see here, my literal string type is not a string, but I initialized with this value, I am a string literal. That means this particular variable, literal string type, can only have this value. It becomes not just its value, but its type. So if I try to change the value of it, you immediately see the red squiggly line pop up, and it tells you, well, type something else is not assignable to type I'm a string literal, right? So TypeScript is your safety net. It's telling you you can't do that. And there may be reasons when you're coding that you want a certain string literal to be of a certain value and you don't want it changed. So you can use TypeScript to enforce that check in your code. So then numbers are the same way as strings. You just say, okay, a variable and number, and then give it a value. Now, the number variables can be used for both integers as well as floating point values. So I can say 5.5 and it will still work. In some programming languages, you have special types for decimal types and non-decimal types. For TypeScript, a number is a number. It doesn't distinguish between them. Then this is an example of how you can do an array. You can do a Boolean array, and you cannot assign it to a string array, for example, or anything else. This is going to always be a Boolean array, and TypeScript will enforce that rule. So the next thing is we've got the null and the undefined. So these are two concepts which sometimes can get confusing. Null implies that something is currently unavailable. So there's no value there at the moment. And undefined usually implies that a variable has not been initialized. So if you declare a variable, but you have not given any value to it, by default, it will have the value undefined as opposed to null. So you can see here, of course, in JavaScript, we have the double equals and the triple equals. So double equals is like loose comparison, and triple equals is a strict comparison. So if you do a loose comparison, undefined is null. But then if you do a strict comparison, undefined is not the same as null. So just keep that in mind. I know a lot of errors get generated because you think of undefined as and null in your mind as one and the same thing. But then to JavaScript, it's slightly different, and you got to watch for that. Next, let's look at examples of enums. And this is where if you had a set of values and you want to restrict yourself to that set, enum is a good candidate for a type for that. So here I have defined an enum color, and I gave it red, blue, and green. So now that I defined it, I can create a variable C of color type, and I can initialize it with the color blue. Now, if I want to use a type that I had not defined, for example, the white, it says, well, no, you can't do that because white is not assignable to color because I did not define white in the color set. So it won't let me do that. So that's, again, good when you want to restrict yourself to certain values. Then tuples. Tuples are pairs, right? So if you wanted a number and a string or a number and a number to go together, then you could use tuples. So in this example, I defined my tuple to be a pair where number is the first object and string is the second object. So I can say, okay, my tuple equals 1 and TypeScript. Now see what happens when I change the order. It says no, because TypeScript knows that the first argument has to be a number, and TypeScript, the string, is not a number, of course, so it'll warn you. So that's the tuple type. Then let's talk about type inference. So TypeScript is smart. You don't have to always specify the type of your variable. It can figure out what the type is based on the value that you assigned. So in this example, I said, let num equals 100. I did not tell TypeScript what is the type. So let us see if TypeScript will allow me to change the value to a string. I declared it with a number and I want to change it to a string. And TypeScript says, you can't assign connect tech a string to the type number. And why is that? Because even though I did not specify the type, TypeScript was smart enough and it inferred the type. And so you cannot willy-nilly change the type that way. If you really wanted to use any type for a particular variable, you have to actually call it any. So if I said let num equals any, then if I gave it the any type, it'll say, okay, that's fine. Because you told me that this num can be any, I'll let you assign a string to it. But if I remove this, it's going to give me an error. TypeScript also has union types, and where you can say that sometimes you want your number or a string. Maybe you have a case where your variable is sometimes a number, sometimes a string, it's sometimes a Boolean. In those situations, you can use union types, so it gives you flexibility. You can also use string literals in union types. So for example, I'm creating a type shape where I've got a rectangle or a square or a circle. So these are just strings, and I'm saying my type shape is either one of these three things. And now I can pass a shape down here. And if I say use the word diamond in here, which was not part of my shapes, TypeScript catches that for me. So it gives you basically a lot of flexibility to do your own shapes. You can define it using the type keyword. You can do union types. A lot of this permutations you can do for your types. The last thing in the types I wanted to talk about is type guard. And what this is let's say you had a combination type. Let's say your input could be either a string or a number. Now, as a string, you can call some functions on it, like you can say the length of a string, you can say substring, whatnot. On a number, you cannot call the same functions. So how does TypeScript let you work with this input, which can be either a string or a number? How can it let you work safely with that? And it does that by using what's called a type guard. So here, I'm checking the type in the if block. I'm saying if type of my input is a string, you see here it's letting me use the substring method, which of course only works on a string. Else, I'm saying I'm calling this number to exponential, which is something that works on a number. So basically, if I try in this else block to use a substring, it doesn't even give that to me because it knows that input is a string only in the top half of the if block, and input is a number in the bottom half or the else block. So it gives me the appropriate functions based on the if, and that is what is a type guard. It's smart, right? So this lets you put in some smart code where your input can be one of two things, and you can work with both of them in a if-else block. So that's what all there is about types. Let me go back to our PowerPoint and see what's up next. The next concept we are going to talk about is the TypeScript class. Now in JavaScript, we are all used to a very functional style of programming, right? But if you're familiar with object-oriented programming languages like Java and C#, you probably are very used to classes. You're used to the object-oriented way of defining a class and methods and variables within the class. So that was not available in JavaScript before. But now with TypeScript, you get that class and object-oriented kind of programming tools into JavaScript. So let's take a look at some of what a class looks like in TypeScript. So I'm going to switch over to this other file that I have here, which is called class example. So let's start by a simple example called a class person. So you use the keyword class to define a class. And you give it a name. So this is my person class. And it can have some values or attributes. So first name is an attribute or a property of this person class. A person also has a last name and an age. So by default, if I don't specify any access modifier, the public and private, they are called access modifiers. So they control who can get access to your properties in your class. If it's public, that means anybody from outside can access it. If it's private, and sometimes you may want to control, right? You may have some things which you don't want anybody else outside of your class to change. And JavaScript doesn't have anything to let you control that, but TypeScript gives you that ability to create classes and use access modifiers and control who gets access to your properties. So first name, I didn't specify any access modifier, so it's public. Last name, I explicitly said it was public, but this is really not needed because the default is public. But I said the age is private. I don't want anybody to know what the age is. The name is a public thing. Everybody can know the name, right? So how do you create an instance of this class person? You have to specify a constructor. A constructor is a special function which tells TypeScript how that object is constructed. In this case, my simple class, I just have a first name and a last name coming in. I assign the first name to the F to the first name, L to the last name. So that's a simple, straightforward constructor. Now, in some languages like Java and C#, you can have more than one way of constructing an object. Let's say a class has 4 properties. Maybe there's one constructor which only takes in 2, one constructor which takes in 3 parameters. You can have different flavors of constructors, but TypeScript does not allow you to do that. It says you only get to define one constructor and that's all. There's no overloading allowed. So if I were to specify a second constructor here, it'll give me an error. Yep, it's not allowed, right? Multiple constructor implementations are not allowed. So along with your properties, and constructor, you can define methods in your class. So for example, this method getFullName, it combines the first name and last name. It returns a string. So you can see here you have a method name. You specify the type that the method is returning. So this is good because normally in JavaScript, if a method is supposed to return a number, but it returns a string, you have to be careful and make sure that you're returning the right kind and hooking it all up together. But with TypeScript, if I try to return a number here, it's going to tell me that that's not going to work. So for example, if I tried, firstly here, it's saying, oh, you have to return something. And now if I say return 10, it will say, yeah, type 10 is not assignable to type string. So it does that checking for you if you specify a return type to your method. So these are all the different methods that you can define in a class. And this is how you can create a person, right? You can say a person is a new person and I'm giving it my first name and the last name. This is the constructor. The constructor is getting called. Now you can also do inheritance. There are situations where you may have a base class and you may define an extension with specialized methods in it. So for example, here, I have a class athlete that extends from the class person. So automatically, all the properties from person come into the class athlete. And you can give a special implementation. So for example, here in the person class, I have a method called sayHello. And it's saying, hello, I am whatever the name is, and I'm a person. But an athlete, we want the athlete to say, I'm an athlete. So you can provide a different implementation for the same method, and that's called overriding a method. And this is how you can do that. So now, if you didn't want to provide a special implementation, but if you wanted to call the super or the parent class method, you can use the super keyword and it will return super dot say hello, which is basically calling the parent classes method. So that is an example of how you can have classes, and you can have child classes which inherit from the parent class, and you can get all the properties of the parent class. You can get all the methods of the parent class. You can call methods of your parent class, or you can override the methods and provide your own implementation in the child class. So that's classes. So we looked at properties of fields, we looked at methods, we looked at constructors, we looked at access modifiers, which are public or private, and we looked at inheritance. Let's look at the next concept is interfaces. So interface is similar to a class, except it has no code, no implementation. And interface is used to define a contract. And this is very useful if you, let's say, are creating a library or something which is shared between teams, and you want to say, okay, my code is going to give you these methods and it will have these properties. I'm not going to tell you how I'm going to do it, but I'm just going to tell you what it is, and you work with that. So interfaces are good to define those boundaries and those contracts in large scale applications and software systems. So they define the shape of the object. They don't define the implementation or how it is implemented, right? Interfaces can extend multiple interfaces. And with interfaces, we look at a special concept called structural or duck typing, which is unique to JavaScript, which actually I think is a pretty cool feature. So we'll look at that next. And so let's jump into code again. So I took the same person concept, but I now made an interface out of it. So the way you define an interface is by using the keyword interface. You say interface I person. And now I've got properties that I have defined here, and I have got methods. If you see here, there's no implementation, unlike the class. You only have the method signature. A signature is when you tell the name of the method, its return type, and what it's taking in, but you don't actually define the method there. The way that you can have a class implement an interface is using this implements keyword. So in this case, I'm creating a class called teacher that implements the iPerson interface. So the purpose of this interface is that it's saying anybody who wants to be known as a person needs to have these attributes and need to provide these methods. If you can do, this is the contract of what it means to be a person. So any class, if it wants to be a person, it needs to implement all those methods. So if you see here, class teacher actually has the implementation here for the interface methods, right? So now you can create an object of type teacher, or which is of type interface, and you can pass it the first name, last name, and the age. So you've created a person. That's great. Now look at this one, this next example. This is where the duck typing comes in. I'm just defining some object, right? This is just JavaScript code where I just defined a some object, and it has the exact same properties as the interface. But I never said that my some object is implementing that interface. I didn't explicitly say that. So what do you think will happen if I assign this some object, which has no type, to a teacher, which is of type iPerson? Will TypeScript let you do that? And the answer is yes. And the reason for that is TypeScript does what's called as duck typing or structural typing. And what that means is duck typing basically says, if something looks like a duck and quacks like a duck, then it must be a duck, right? So which means this some object, it looks like it has all the same attributes and all the same functions like a person. So it must be a person. You don't have to explicitly implement the person interface I just can tell that you are like a person object because you have all the right attributes. So that is what is duck typing. And that is very useful because sometimes, especially when you're making an HTTP call to some service and you're getting data back, you cannot always implement the exact structure that you're getting back. So if you can make sure that you have all the properties that is coming back in the response, you can just cast it and use that type. So that's a very useful feature, in my opinion, in TypeScript. Quick time check here. I think it's 1:45. So Jennifer, do I have 5 more minutes?
Yeah, sure.
Okay, all right. I think what I'm going to do is go through interfaces and a quick look at generics and bring this back. So that's duck typing. So it's a very useful feature where if you have an object, it has all the properties of an interface, then you're good to go. You don't have to explicitly implement it. Let me skip this remaining portion of it. Actually, I'll touch upon this topic because I think it's useful. So if you saw the classes before and the interfaces now, they're quite similar. And a lot of programmers wonder when they are defining their contracts, whether they should go with a class or an interface, what is better? So my recommendation is always use an interface if possible, because they reduce your bundle size, your application bundle size. So prefer interfaces because they give you a more efficient implementation and your application bundle size is smaller. Okay, and with that, let me hop back to my presentation here. And let's look at generics. So generics have been around in other programming languages like Java again and C# for a long time. They let you create reusable components. Let's say you want to make something, but you want to make it work with different kinds of types, then you can use generics. And with TypeScript, you can now use generics to create those reusable components. I'll show a quick example of that. And this is really, generics is not something we would use on a regular basis, I guess, in application development. It's more useful for those who are building libraries or tools or some specialized software. You may not use it that much in your regular application development. So let's say I wanted to create a function called identity. And let's say it takes in a number and all it does is it returns the same number back. How do I add types to it? So right now here I mentioned a number. It takes in a number and gives me back a number. Fine. But now I want to make it work with string. How can I do that? Well, your first thought may be, okay, why don't you use the any type? Any type works with any type, right? But the problem with using any type is TypeScript doesn't know what type it is. It just lets you put whatever you want. So you lose the benefit of having a type. So for example, let's say my input is a number 6, and I pass it through this identity2 function, which is an any type. And when it comes back, my output is no longer a number. It lost its identity because I used an any type. So that's not what you want. Using the any type, you're losing information. That's not what you want. So the right way to do that is to use generics. And the way you use generics is by making your type itself a variable. So you create a variable t for the type, and you use that as a variable. And that's how you make your function generic. And now this function can work with strings, with numbers, with whatever you want without losing any information. That is the key part of it. So I'm going to stop there with generics because I'd like to show the resources slide. I think that's very important. Actually, this one quick note about definitely typed. So you know how JavaScript has so many libraries and it has, and your question is, okay, what if I want to use type system in all these other libraries? Is there anything we can do to make that easier, to make TypeScript work with all the other JavaScript libraries that have already been written? And the answer is, A lot of folks out there have gone in and have put type definitions for the existing JavaScript libraries. And there's a repository on GitHub. It's called Definitely Typed. It's probably the most popular TypeScript repository. And it's got types for all the popular JavaScript libraries. So what this allows you to do is use an existing JavaScript library, but add types on top of it. So you get all the benefits of using TypeScript with the old JavaScript libraries, like for example, Lodash or anything else. And this is a community effort. I mean, a lot of folks have contributed. It's probably one of the most contributed project on GitHub. And with that, I'll get into the resources. So on the TypeScript website, there's a TypeScript Playground. I found this very useful when I was learning TypeScript myself. You can write small snippets of TypeScript code and see how it plays out. That was my favorite. Then there's a great book on GitHub. And this is by this gentleman, Basarat Ali, which I find, again, very useful, and it's free. We looked at Definitely Typed for type definitions. If you're the podcast kind of person, this is my favorite TypeScript podcast. It's called TalkScript, hosted by SitePen. And they talk about not just TypeScript, they cover a lot of front-end topics. They do conferences, they go to the conferences and they profile speakers and issues. So definitely check that one out. And lastly, if you like getting emails in your inbox, a weekly update of what's going on with TypeScript, you can do that with TypeScript Weekly. So that, I believe, is the end of my presentation. Well, thank you all so much for your attention and time. I appreciated this opportunity. Thank you, Jennifer, as well.
You're welcome. Thank you so much, Sangeeta, for that presentation. Now we're going to open the floor up for any questions that you have for Sangeeta today. So you can place your questions in the chat box, and we also have a Q&A area as well. So we're going to take about a few minutes, and then right after our Q&A session, we are going into some closing updates, things that are coming up for front end that I just wanted to tell everyone about before we close out today. And Sangeeta, just to kick everything off, I do have a question. As far as TypeScript is concerned, and the way things are changing over the time, what are some things that you see possibly that will be implemented in TypeScript coming up for 2020? Because every year, different coding languages, they have different changes, and scripting, of course. So what's some things that you are noticing that are coming up for 2020 with TypeScript?
So one feature that I'm really excited about coming out in 2020, or actually might be in this release, I'm not sure, is what's called as optional chaining. We've all been there with JavaScript where you have an object which has a child, and then that child has another property. And if you wanted to access that property, which is like the grandchild, you have to go, first you have to ask the parent, hey, are you available? Are you null? Oh, okay, you're not null. Now, okay, is your child available? Is that null? Okay, no. And then you kind of like have to keep checking every step of the way. But now with later, one of the new features, you can use a question mark and it says, okay, give me the property if it's available. If it's not available, fine. And you can chain that. So that's called optional chaining. And I'm excited about that coming out. I know TypeScript is also trying to be more to support both the classical and functional programming paradigms. So JavaScript has mostly been functional, right? And TypeScript brings some of the object-oriented features into JavaScript. And I know that going forward, they want to enhance the object-oriented features in 2020. I'm hoping to see more of that.
Okay, that's awesome. Yeah, definitely.
Yeah.
And also, too, I just wanted to let everybody know today, too, because I know if there is something you happen to think of, please go ahead and place your questions in our Slack. I definitely would love to get those over to Sangeeta and get an answer back for you. So if it's something, that you can't think of right now, definitely Slack and take advantage of our front end at WWCode. .com email. We can definitely get those questions over.
Yeah, absolutely. Yeah.
And then I'm going to just check here just to make sure we're not missing anything on this end. And also, Sangeeta, if there's any two, I know you showed there the podcast and also some other great resources there. Are there any conferences that come to mind that are just, you know, something that would be standouts for TypeScript that people could look into if they're interested in knowing more and they just want to go to a full immersive day of a TypeScript type summit or conference that you can think of that may come to mind?
I don't know if a TypeScript only. I'm sure Microsoft has MS Build conferences.
Right. Yeah.
They do the, you know, they focus in on TypeScript. In fact, actually, I'm glad you asked that question because the creator of TypeScript, his name is Andres Heilsberg. He's also the person who created Turbo Pascal and Delphi. So he actually has a great video, which is, I think it's available on YouTube. If you go to YouTube and search for MS Build TypeScript, and then probably you'll see his name. His name again is Andres Heilsberg. So he's got some great videos out there for TypeScript, introductory videos, as well as what's coming, what's in the future. So I'm sure the Microsoft conferences are usually the place for TypeScript only, but TypeScript is also included in a lot of front-end and web developer conferences. I mean, for example, in Atlanta, we had recently had the Connect.js conference, Connect Tech conference, excuse me, and there were a lot of good TypeScript talks on it. I know that, again, I'm being local to Atlanta. I've got examples from here. I'm sure there's all over the US, there's some great conferences, but we have DevNexus coming up, and I know they have a track on advanced JavaScript, and there's some sessions on TypeScript in there as well. And Jennifer, do you know of other front-end conferences from around US?
And like you said, I do know Connect Tech is one of them. I was going to say there may be something, you know, I know NG Atlanta is mostly Angular based, but I feel like there was a track or a piece dedicated more so to TypeScript, you know, because sometimes we have additional tracks that have just different talks that allow some inclusive content other than just Angular based. And I want to say there are some others I can't think of right now because there are just so many, you know. And I know there are some internationally abroad. I want to say Codeland Conf, but I know that's more so of a new. But, you know, a lot of conferences these days, they're very inclusive about the information that they have. But definitely Connect Tech is one of them. I see we do have a comment in from, and excuse the pronunciation of your name, Sharupa Data or Data. I've heard good things about the TS Conf. So have you heard of that one, Sangeeta?
No, I've not. So I have not been or checked that out. But I'm sure if it is dedicated to TypeScript, it probably is the most valuable conference for TypeScript, right? I mean, it's focused on TypeScript. So thank you for that. Yeah.
Right, and definitely MS Build, like you said. Okay, well, we're going to move into our closing comments and updates for today. Thank you again, Sangeeta, for all of that information that you have given us today. Definitely enjoyed your presentation. I'm just going to share some closing updates with everyone. What we have coming up here for front end, our next events, Slack study group every Friday at 2 p.m. That's coming up today. You can look out for pros and cons of serverless. We have our host, Favor. She is going over pros and cons of serverless architecture. Let's talk accessibility in November. So something new to front end I wanted to bring about is accessibility in creating web applications. That's something that, you know, more and more there is a concern for now with creating web applications. So just want to bring some tips and resources that everyone can take a look at throughout the month in our Slack, Twitter, and our Instagram channel. Also, Connect NYC, our developer conference, is coming up next month. You can take a look at that in New York. We'll have that December 7th. Also, too, just want to make sure, and there could be a slight retraction in that. December 5th or 7th, I will get that correction out. If it's not the 7th, I'll definitely be posting that in our Slack and our Twitter and Instagram, because we definitely want to make sure that everyone knows about that. We did post, most recently, I posted about the scholarship for that. So just be on the lookout for all of that information coming forward. Also, we want to thank our sponsors today, BCG Digital Ventures and also the Home Depot. And thank you all for watching this presentation today. Again, if you have any further questions or comments for our speaker today, Sangeeta Nori, definitely take a look at putting them in our Slack channel and also emailing them to frontend@womenwhocode. And thank you again for your attention. We will see you online.